Hello everyone. So, in the last lecture we have seen about the basic protection system. What are the basic elements of protection system we have seen, and there are different types of elements are there like circuit breakers, protective relays like load interrupters, air brake switches, knife switches, and at the last we have seen isolators and circuit breakers. There are different types of circuit breakers we have seen. So, those are the different elements which we are having in the protection system. In today's lecture, that is unit 1 lecture 2, we will see about the basics of protective relay, and next we will see about the zones of protection. There are different types of zones of protection, and next we are having the essential qualities of relay. Okay. So, here what is actually the basics of protective relay? So, what is actually the protective relay means? A protective relay is an automatic sensing device which will sense abnormal condition such as short circuit faults in an electric circuit and gives the trip signal to the circuit breaker to operate the circuit breaker and isolate the equipment from the faulty section. So, protective system means what? It is a combination of a relay plus circuit breaker. It is a combination of relay plus circuit breaker. So, in the last class we have seen about the circuit breaker. What is actually the circuit breaker we have seen, and here a protective relay. What is protective relay means? It is a automatic sensing device which will sense the fault or abnormal condition such as a fault, and which will give the trip signal to the circuit breaker to operate the circuit breaker. And if you see the circuit diagram of that basic protection system is this. So, here we have connected the circuit breaker, and there is a current transformer which is connected in the line to be protected, and here the fault. As we are having the fault in this system, in the line, that line has to be provide protection. So, here we are having the trip coil, and there we are having the DC supply for the trip coil, and here these are the contacts of the relay, that is trip contacts, and next this is what your relay coil, what we are calling as ROC, a relay operating coil, and there is a bus bar. Here we are having a bus bar, right. So, in detail if we see the basic connection diagram, that look like this. The same thing whatever there in the previous diagram, but here I have just added the spring here, and the trip coil is drawn like this. And here what is happening is, under normal operating condition there are two cases are there. First, if you consider under normal operating conditions, there is a current which is flowing in this CT primary, that current is flows through the secondary of a CT, and which is not sufficient to move this whatever the contacts are there, the relay contacts. These relay contacts are normally open whenever there is no faults. Whenever there is no fault, these relay contacts are normally open, because the spring is pull up by the plunger, pull up the plunger, and which will moves up, and it will be work as a normal condition, and it is normally open. These relay contacts are normally open, and these circuit breaker contacts are normally closed before the fault is taken place. And whenever there is a fault occurs here, there is a excessive amount of current which is flowing in this current transformer. So, because of that excessive current flows through the current transformer, and the secondary of a current transformer carries the more amount of current which is sufficient to move this plunger to down. If this plunger moves down, then the spring force is less than this operating force. This is what operating of the plunger. So, this operating force is more when compared to the spring force. That spring force we are calling as restraining force. The spring will provide a restraining force, and this coil or relay operating coil, what we call as ROC. This ROC will provide the operating force. This operating force is more when compared to the restraining force provided by the spring. So, if this Fr is less than this F naught, then the plunger is going to be moves down. This plunger is going to be moves down, that means it will closes the contacts of the relay. Then that DC supply, whatever the DC supply is there, that DC supply is given to the trip coil. Whatever the trip coil is there here, that trip coil is going to be gets energized. Whenever this trip contacts of the relay is going to be closes, this trip coil is going to be energizes. Whenever this trip coil is going to be energizes, that will moves the mobile contact of the circuit breaker away from the fixed contacts. That means, it is opening of the circuit breaker and it is disconnecting the faulty section from the healthy section whenever there is a fault is taken place. So, this DC supply, whatever the battery is there, that will provide a DC supply, that will provide only when the contacts of this relay are going to be closes. So, here under normal operating conditions, if you see here the relay under normal operating conditions, it will NO, normally open, the contacts of the relay is normally open, and here we are having the contacts abnormal condition. Whenever you are having the fault, then the relay contacts are going to be closes. If you consider the circuit breaker, it is quite opposite. So, here under normal operating conditions, the circuit breaker contacts are closed, normally closed, and whenever the fault is taken place, the circuit breaker contacts are NO, normally open. As I said, F naught operating force is produced by the relay operating coil, that is ROC, and here Fr, that is restraining force, will be provided by the spring. Whatever the spring is there here, that will provide the restraining force. So, resultant force, if you consider the resultant force produced by the relay operating mechanism, that is F resultant. So, F resultant is equal to what? Operating force minus restraining force, F naught minus Fr. So, based upon that resultant force, F resultant, we can decide whether the relay is going to be operates or circuit breaker is going to be operates or not. We can decide with that. So, if F resultant is greater than 0, the relay contacts will be closed or a relay operates. The circuit breaker contacts are open. So, whenever the relay contacts are closed, then the circuit breaker contacts are open. That relay gives a trip signal to the circuit breaker, so that circuit breaker contacts are gets open. If F resultant is less than 0, then the relay will not operate, then a relay contacts in open position. Okay. The relay contacts are in open position, the relay will not operate, means circuit breaker contacts are in closed position only. If the F resultant is equal to 0, then the relay is at verge of operation. It cannot decide whether to operate or not, that is at verge of operation. At finally, it is not going to be gets operated. So, that is about the basics of protection system. And next, if you coming for a zones of protection, there are two zones of protection in the power system. So, primary protection and backup protection. Primary protection and backup protection. The backup protection is means what? Primary protection means what? We will see. So, first primary protection. What is actually the primary protection? This forms a primary or main protection and serves as a first line of defense. Whenever the fault is taken place in the power system, it will act as a first line of defense. That means, at that instant it is going to be acts, depends upon the time delay which we are providing for the relay. Time delay which we are providing for the relay, depends upon that it will going to be operates. If this is going to be fails to operate, if this primary protection is going to be fails to operate, then the backup protection is coming to the picture, coming to the action, and this backup protection will works as a second line of defense in case of failure of primary protection, and this will operates whenever the primary protection fails. This will operates and which will disconnect the supply from the faulty section, and it will separate the healthy section from the faulty section. So, this is what the different zones of protection we are having in the power system. So, as we are having here a generator protection scheme, and next we are having the high voltage switchgear protection, next you are having the transformer protection here, and next EHV switchgear protection. So, this is you are having the EHV switchgear protection again. So, these are the different types of protection system. There are different zones, generator zone is there, and there is a generator protection. For that generator protection, we are going to provide the circuit breakers relays, and next we are having the transformer protection. For this transformer also you are having the two relays, one is a primary, another one is a secondary side, and here you are having the different relays and protection system, that is circuit breakers for EHV switchgear, extra high voltage, and there is a transmission line protection is also there. Different, it is power system is going to be divided into the different zones, depends upon that the protection system is going to be operated. So, we can explain primary and backup protection with the help of this diagram. So, here you are having the main bus, and there is a circuit breaker, and there is a relay, relay A. This relay A is a overcurrent relay with a time delay of 1 second, 1 second time setting, right. And we are having the different relays in the each line. There are 4 lines are there here. In these 4 lines, we are having the 4 relays and 4 circuit breakers. Each relay is a overcurrent relay and with a time delay of 0.6 seconds. So, this relay A will act as a backup protection. These relays, 4 relays which are there in the lines, will act as a primary protection. If there is any fault occurs in these 4 or in any one of these 4 lines, then if these relays, whatever, let us take, there is a fault occurs in the second line. If this circuit breaker and relay which is there in the second line is fails to operate, then that will operated by the second relay, that is called a backup protection. This A coming to the action, and it will takes a necessary action, and it will separates a faulty section with the help of the circuit breaker. So, whatever the circuit breaker is there in the backup protection system, that will operates. Here there is a disadvantage. What is the disadvantage of operating of the backup protection? Because if you are having any fault in this second line, if we operate this second line relay and circuit breaker, then this only second line connections, whatever the loads are there, that loads are only disconnected. But if you disconnect the circuit breaker here in the backup protection, then that will separate the total 4 lines, whatever the 4 lines are there, whatever the loads are connected to these 4 lines are going to be disconnected. That is a unreliable operation. The reliable operation is what? The operation of the relay which is present in the second line is a reliable operation. So, we have to disconnect only the second line circuit breaker for the faults, that is a necessary action we have to take. If this is going to be fails, then the circuit breaker which is there in the backup protection, that will operate. So, that is a unnecessary action or unreliable action we can say. Okay. That is a disadvantage. And next, if you see essential qualities of the protection system. So, if you see the protection relay, there are 6 essential qualities it must have. First one is a selectivity, next sensitivity, next reliability, 4th one is stability, 5th one is speed of operation, 6th one is economical. So, if you see the first one, the selectivity. What is actually the selectivity? It is the ability of the power system, a protection system, to select correctly that part of the system in trouble and disconnect the faulty section or the faulty part without disturbing the rest of the system, That means, it has to only disconnect wherever you are having the fault, that part only it has to disconnect. The other part, whatever it may be there, that has to continuously provide the supply. So, that is what the selectivity. So, we can in detail we can explain with the help of the circuit diagram. Whatever this diagram, single line diagram is there. So, here we are having the source. There are 2 sources are there, one source is here, another source is there, source 1, source 2, and you are having the bus bars. This is a zone protection 1 for bus bar 1 here, and next the next zone protection for the bus bar 2 and zone protection for the bus bar 3, and in between that you are having the 2 transmission lines, zone for transmission line 1 here and zone for transmission line 2. There are total Here we are having the 6 relays R1, R2, R3, R4 and R5, R6. There are 6 relays are there total here. R1 and R2 will provide a protection for bus bar zone 1, bus bar 1 in the first zone, and here R3, R4 will provide a protection for the zone protection of bus bar 2, and here R4 and R5 and R6 will provide the protection for the bus bar 3. And again you are having the 2 transmission lines, zone of transmission line 1, that is R2 and R3 combinedly will provide the protection for the transmission line 1, and here R4 and R5 will provide the protection for the zone for transmission line 2. Let us take, there is a case that there is a fault occurs in the transmission line 2. Which of the following relays has to operate? Which zone it has to select? There are different zones are there, bus bar zones and transmission line zones. Which relay has to operate, which gives a particular selectivity for the relay? So, if the fault is taken place in this second transmission line, then the relays which are there in this second line, that is R4 and R5 should operate. This R4 and R5 should think that the fault is taken place within their zone, and the other relays, whatever the relays are there, the remaining 4 relays should think that the fault is taken place outside of that zone, outside of their zone. So, if that will select in such a way, then the reliability operation is going to be present. Next, second is sensitivity. What is actually the sensitivity? Sensitivity means it is the ability of the protective relay to operate with a low value of actuating quantity. So, if you are having the low value of actuating quantity, for that also it has to operate. For small quantities also, if the value of pickup value is more than a small quantity also, either it may be voltage or current, or it may be frequency, or it may be a phase angle, etc. If it is exceeds a small value more than the pickup value, then the relay has to operate. That is what your sensitivity, it has to more sensitive. Next, if you see reliability, what is reliability? There are, let us explain with the help of this diagram. There is a substation, let us take, or a source, whatever it may be. Here R1 and relay 2, there are relay 1 and relay 2, and there are 3 loads are there here. Here we are having the relay 1, relay 2, and there is a fault is taken place after the relay 2. If there are 3 loads, which load has to be disconnected if the fault is taken place? With the help of which relay we have to operate? So, that is the operating of the relay 2 will gives a reliable operation. If you operate a relay 1, 2 loads are going to be disconnected here. If you operate relay 1, this L2 and L3, 2 loads are going to be disconnected. That is an unreliable operation. If you operate the relay 2, that will gives a reliable operation, that only L3 is going to be disconnected, because the fault is taken place near the L3, we have to disconnect only L3. That means we have to operate only R2. The R2 operation will gives the reliable operation, and R1 operation will gives the unreliable operation. The relay operation must be such that its operation has to give more reliability compared to any other protective device operation. Which relay we are choosing, which relay is going to be operates, that must be give reliable operation. Next, a fourth one, if you see, so here the operating time of the protecting system should be maintained as always less than the critical clearing time. So, if you see here critical clearing time is going to be obtained from the stability analysis. There we are going to get the critical clearing time. So, that is a very less. That means, you have to operate the relay as soon as possible in order to avoid the damage to the equipment. Okay. That is a stability. Next, speed of operation. That means it has to operate very quickly. The relay has to operate very quickly whenever the fault is taken place. The relay should disconnect the faulty section as fast as possible for the following reasons. The first one is electrical apparatus may be damaged if they are made to carry fault currents for long time. If you are allowed to carry the fault currents for longer time, then the equipments or apparatus are going to be damaged. Because we are having the costlier equipments, we have to provide the protection against them. So, we should not lose them as they are costlier. And next point, that is next reason is a failure on the system leads to a great reduction in the system voltage. If the system voltage is going to be reduces, then what happens? Then the voltage, low voltage problem is going to be arises, right? That is not desirable. Next, the third reason is the high speed relay system decreases the possibility of development of one type of faults to the other type of severe faults. It will reduces or decreases the possibility of development of faults from one type of fault to the other type. Next, if you see the economical operation or economical concept, if you see for the relay should not cost more than the 5% of the total cost. If it is cost more than that, that is not desirable, but in practice it may goes more than the 5%, as the equipment or apparatus needs to be provides a protection. At the provision of protection is utmost importance as they are costlier. Whatever the equipments you are providing the protection are costlier, we need to provide the protection for that, even though if the cost is somewhat more than this 5%. As these equipments are more costlier, because like if you consider generators or main transmission lines, these are going to be costlier equipments, like in rupees in terms of crores. So, for that if you provide the protection cost for 5%, that is not that is a good one. Okay. That is a good thing to provide the protection as to avoid the damage or losing of the equipments. So, this is total 6 essential qualities which needs for the protective relay. So, if you see the summary of this lecture, we have seen the protection system. It is a combination of relay plus circuit breaker. Whenever the faults are taken place, the relay will gives a trip signal to the circuit breaker, so that the circuit breaker will operates. It is a combination of relay protection system, means it is a combination of relay plus circuit breaker. And next, there are two zones of protection we have seen. One is a primary protection and second one is a backup protection. So, primary zonal protection means it will works as a first line of defense. Whenever the fault is taken place, it will disconnect the system from the fault and it will separates the healthy section from the fault section, and it will act as a first line of defense. And second one, that is a backup protection, it will comes into the action whenever there are primary protection fails to operate. It will operates as a backup protection. The operation of the backup protection is undesirable. We should not take the necessary action for operating of the backup protection, as this backup protection operation is unavoidable to provide the protection, but the operation of this backup protection will give a disconnection of the more number of loads. As we have to provide the continuity of the supply to the consumers, we should not have disconnection of the supply for the consumers. We have to care utmost priority for the primary protection only. We have to provide the protection by the primary only, that will disconnect only the small portion of the loads. And in the last, we have studied the different essential qualities or the characteristics of the protective relay, right. There are 6 characteristics or essential qualities of protection relay we have seen. So, thank you for listening this class.